In any case, I'm very bothered and irritated by this convention, but it's a convention that's there everywhere, and so it's sort of, well, I guess one of my big questions, just to sort of digress that way, is can we scaffold this a little bit for students by getting them to use a convention that seems to somehow visually resonate with us in a way that helps us to not make those mistakes, and then try to apply that to that horrid convention? Should we ban that convention? Should I start a movement?
I think you should teach it, though, because it's so valuable for the... There's two things that are valuable in what you've... there's a lot of stuff that's valuable in what you've said in the time I've been here, and one of them is that we need to learn the conventions because we're moving on to a test of some sort somewhere. And that's one thing.
That's the reality of the situation.
And another thing is to see an expert like you telling us that there's stuff about our community that you don't like and that you want to change. And that's important for a student to understand, I think.
Well, if it were up to me, I'd get rid of it because I think it
They'll
draws
love
the
it.
eye.
They'll love it. That'll get them to learn it, you know?
Maybe it will.
Like, oh, yeah,
This is a
none of us
challenge.
like this. Oh, no, wait, here's how it goes. Yeah, but this, nobody uses it.
So I'm going to
Everybody
skip
uses it.
ahead.
And the way the curvy one is the nicest, I think. 'cause
Which
it
one?
Well, it takes away the one on the lower left.
This one?
No.
Lower left. It takes away the right angles that don't mean anything and leaves the ones that
Well, that's
do.
another excellent
Yeah.
point. I like that one.
Yeah, me
like
too.
for instance,
Yeah.
But I've never seen one drawn like that.
I haven't really either, except there was something besides this that I saw just recently, now that I've been looking into this stuff more.
So interesting.
You could build a mobile.
Well,
And then they would like float around, which would
But
also...
so often when you let the students do it, they come up with stuff that makes sense, believe it or not.
yeah.
Yeah. I mean, just a general comment, one problem with your curvy one there. Your branch below the B, C, F, and C. So follow it all the way down. Yeah, that long one right there, go down. You notice that one's twice as long as the branch between those, whereas all the others are exactly the same length.
So what's the problem with that?
If there is no time scale on the axis, wouldn't each branch be exactly the same length?
So it would look really messy if we drew it exactly the same length. And
But
because
it
there's
is
no
the-
time scale,
But it is the
doesn't...
same length on the ones above it.
Wait.
Not really.
I'm confused.
Okay.
Can you go up and point
Sure.
to
Yeah,
what
yeah.
you're talking about?
Sure, I'm just looking at a general trend here.
Uh-huh.
So, for instance, if we look at this curve right here compared to this curve right here, this is about twice as long as that. If we look up here,
Wow.
this is the same length as that. So if it's not a time scale, and you keep those exactly the same, then you can't really have a time scale because the time scale would be really, really different.
So again, no, that's a good point. That is something interesting about that depiction that is not true in the other ones. So that's problematic, that people want to read in meaning to the lengths of those branches, and in fact there's no real meaning because they're not scaled in any way towards time. It's just a way to make it visible. Otherwise it could get really crazy. The one that I showed for my dissertation was meant to represent time in some respect, although my branching events didn't really mean it. I didn't know where that ancestor was. That way it wasn't really, truly anything meaningful about time.
Is there significance that they all have to go up to a certain even level, except for the bottom right-hand one?
So I think there is, and I think that's because we are treating these all as equal entities. A lot of times they're all living organisms, or they're all taxa that existed at some time, and we're not trying to find out who of the group is an ancestor to anyone else. We're just trying to generate hypotheses about how they're related to each other. So they're all sort of equal in that respect. Does that sort of make sense?
And if you're doing it with living organisms, every living organism presently living organism has had just as long to evolve as any other.
Well, not really, but
Well, but they're all descended from...
they're all
Right.
living, and they all have ancestors.
Yeah, and
So-
those lines have been doing their thing since back the very first
Right.
one.
So in the interest of time, I'm going to skip. There's a couple of really excellent papers, and I think in the thing that got sent out there, I cited sort of the most prominent ones if you're interested. And between sort of this small group, they've identified 4 major misconceptions that people can have, or 4 things that people tend to do reading trees incorrectly. And one is one that we sort of talked about a little bit, in that you can rotate these things around like a mobile at any of these nodes and it has the same meaning. Some people like to produce trees like this, which has the same meaning as this and this. It's just, I mean, it's just how you do it. They call these ladderized trees. There's no, but I mean, doesn't it make you want to think that they're different in some way?
Yeah.
What's the impression you get?
That they need a set of governing rules.
So again, and these four over here are exactly communicating exactly the same information. What usually happens if you're interested in some of these guys the most often in these studies, so you tend to put them in the upper right, and everyone else sort of falls off to the left. But that doesn't mean that anyone else out here isn't as important or doesn't have as many interesting morphological characters or anything like that. It's just that convention is there for some reason.
You think that, I mean, how long has this convention been around for?
60 years.
So, I mean, do you think it happened because people were using rulers to draw these things, and you can draw a longer
Probably.
straight line even quicker than a lot of small
Probably,
little
yes.
lines?
I would imagine there's probably something ridiculously practical like that.
Yeah.
But
Yeah.
so F and G are the most closely related of any pair of that list, right?
Well,
To each other.
no.
F and G are more closely related to each other because they have a common ancestor.
That's a great point.
There's no other pair that I can point to that has one common ancestor. So there is. It seems to me like there is some significance to the first representation compared to the one where you start twisting things up.
It's topologically the same.
It's
It's
Topologically the same, but I'm just looking at the picture.
but it
this
doesn't.
is not,
without
this
even,
is not every feature that these organisms have. They're the features that have been found meaningful in sorting out these relationships. So again, it's that awful word that we barely glossed over, the synapomorphy. It's the shared derived character. So basically, the idea is everyone has the same character, then it doesn't help you map out the inner relationships. What you want, if you want to figure out, you think that perhaps F, G, and E might be closely related, and they might be less closely related to D. You don't care about any characters that relate it to D. You don't want any characters that D has. You're trying to figure out the relationship here. You only want characters that these guys share. And so it's crazy algorithms, right? With each pair, how many characters do they share? I'm not really answering your question.
It's okay. I don't know if it was really a question.
Well, I don't think. I
It's
mean, even
saying
if you
that they are
rotate it
the
around it, you're
closest-
not changing the relationship to
Right.
common ancestors.
Pardon?
You're still going to pass through the same number of common ancestors going from one point to another point, regardless of how you rotate around those common ancestors.
But what you said is actually, I think, the closest to the truth, in that those two that are more closely nested share the most number of characters than anyone else does on the tree, right? Everyone else falls off at some point.
Ideally.
Yeah, well,
Right,
depending
everybody-
on what characters you choose, right?
Right,
You can choose this or
A
not
fell
that.
off earlier, so it has none of the extra features
That's right.
that arrived at the nodes that generated B, C, D,
Right.
E, F,
So,
G.
like your racetrack, they got a punch right there. These guys all did, and no one, and A didn't, right?
Oh yeah.
So
It's
when
really
you wrote
complex if you get into
typology,
real
you
traits
meant
'cause you can have awesome
topology,
characters too.
or not?
I think I did.
Or do
yes.
you use them?
No, I
or
just.
interchangeably?
I believe it's supposed to be typology. Yes,
Yeah.
I wrote it incorrectly. Good point.
So the same character, right?
Just to give you kind of, again, this is sort of part one. I hope to give you some results at some point, but sort of let you see what I've been doing and get any feedback. Take this from this paper by Gregory, where he sort of walks through some of the major concepts and terms and tries to get people to confront those misconceptions by looking at something that's more familiar, the family tree. So you notice one difference here is what we've done is we actually have ancestors at the nodes, which
Yeah.
isn't common, but it does. There are some evolutionary diagrams that will have that. So here we can sort of confront some of those issues, like if you rotated A and B, would that change anything about their relationship to you? If you rotated cousin A and B, that node, does it change anything?
No.
Why doesn't it change anything?
They're not splitting off from your
They're not
arms.
splitting off. So who's more closely related, cousin A or B, or cousin A and you?
A and B.
Why?
Depends on how closely related aunt and parent are.
How about this one? You and your grandparent, or you and your parent? Who's most closely related? You can use your background knowledge. It's your parent, right? So the further back you go, the nearest node, the nearest branching point is going to be your nearest ancestor, and you go further back. I mean, it sort of makes sense, right? How about this one? Your aunt and your grandparent, or your parent and your grandparent?
Same.
Same, right. So if we move on to more complicated diagrams that have this, you sort of worked through several of the ideas here, and it gets more into it a little bit more. Anyway, this is our strategy for developing this. And the reason we're doing it is, as far as we know, there aren't any materials that are developed for use that are research-based in paleobiology courses. They tend to be very much, here's the terminology you need, bam, and they'll give you 16 terms that no one has ever heard of. And,
But that seems
people
very
like
effective.
Valerie,
I'll bet that's very effective because that immediately makes sense. You just see it as it's completely
I hope it
familiar
is.
to everybody.
It's just that
Yeah.
it's not perfectly analogous. Is the problem. There are elements of this tree that are different from the elements that you're trying to explain in the other tree, like
what?
like that the nodes here are individuals. The node was a different. It served a different conceptual role in the.
It's the same
You're
conceptual
just
role.
labeling the nodes
It's
here,
just
and you're not
hypothetical.
labeling them on the other diagram.
Yeah.
But I think there's
Yeah.
still a species at the node.
Well, but in the end, all we really did was label the ends.
right.
These cards are all at the top level.
Yeah.
So
Yeah.
somehow we've got like this extra feature
Mhm.
in this representation that's different from
Yeah.
this one.
This would be you, your siblings, and your cousins.
But this tells you,
That's
yes,
right.
there is something at the node. It's actually an individual in this case, or a species in the other case.
I mean, I think I agree with both of you in the sense that it's different and that could be problematic, but I think it may be value added a little bit because
I think so.
it's making it explicit that that is meant to be an entity, a living thing at that point,
Yeah.
and it is the common ancestor. So I don't know how effective it is. We'll find out. We focused
Yeah, no,
on
it seems
it seems to make sense in a certain respect, and these two analogies seem to build students up to being very comfortable talking about things like sister taxa and a special kind of group is an ancestor and all its descendants. So your immediate family is analogous to that. Or if you have your ancestor, your grandparent, you would all be the extended family.
another
It's a special
feature is that
kind
these
of
could all
group.
be alive at the same time, right?
Yeah.
Which
a good point.
which is rather different than
It
the
is.
picture we were looking at before.
But now we don't have everybody over across at the top of the row like we do
Right.
in the other examples, where
Right.
everyone finds their way.
Right.
to
Everyone
the top.
Everyone who's living is at the top of that previous diagram, but everyone who's living is not at the top of this diagram.
Right.
So I actually was fixated on that and wondered if it was going to be an issue. And I didn't hear all the students working in class. I didn't hear anyone say that though. That they're like, I'm confused because of that. But that gives me an idea what you just said, which is why I'm doing this presentation is so I could get ideas. I wonder if it would be worthwhile to get students to try to plot a diagram, assuming everyone was living, and
Yes.
to make their own tree that
That'd
way.
be a great idea.
What do you mean?
So instead of having the people at the nodes, have them be at the tips. He says. No, he wants to work it out.
So then you'd need horizontal, and
You would need a bunch of horizontal
lines.
Yeah, you would.
Yeah.
Yep. Yep.
Grandparents, just make that one line.
Well, if you guys have any more thoughts on any of this, or if you're interested in taking a survey, just as some random person, I'd be interested in hearing from you.
I'm excited to hear the results.
So we'll see.
this is
Yeah. Thanks. Thanks very much.
A lot of this gets quite
Thank you.
confusing.
Thank you.